Alright, so we'll go on and look at this tutorial sheet number 6. Practice questions on binomial expansions to start with. Yes, so use the binomial theorem to find the values of the following 1.0001. Maybe I just want to give you the questions that we are looking at so that you just know the questions that are in this tutorial sheet. So these are the questions that are here. Okay, these are the questions specifically under binomial. The other videos will be, the other questions are covered in the next video, part 2. Look for part 2. The ones that are from calculus limits. Okay, so we'll proceed. You understand that this is the second part of the tutorial sheet. This is the second. This is 6 if the previous one also dealt with a bit of introductory to binomial, but I want to now look at these. Okay, so whenever you look at finding square root under the binomial expansions, we apply this simplified form of a binomial theorem, where we say that if you've got 1 added to x, okay, raised to the power n, of course, where x is less than 1, such an expansion, and usually this is necessary where we're working with n which is of course negative or a fraction. When not x x shouldn't be greater than 1, but instead x should be less than 1. Okay, the simplified form of the equation is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 3 factorial x to the power 3. This is the equation that we'll use for such expansions. Okay, now looking at the one that is at hand, we have the square root of that. So square root is the same as the power half. 1.001 raised to the power half. Now we have to express it in terms of addition. So that is 1 plus 0.001 raised to the power half. And so from there it becomes easy. So now I will just go up to the second term, to the third term. That's enough. You'll be able to see why. Let's try to substitute. So our value of n is half in this case. So we have 1 plus half, and then our value of x is 0.001. Okay. If you want, you can take that into a fraction, but I'll take it as it is. Plus our n is half. Again, half minus 1. I'm just substituting there. Divided by 2 factorial. And then we've got x squared, which is of course 0.001 squared. 1. Now, you ask yourself a question. What is the half of 0.01? What's the half of it? So the way you can use it, think of this whenever you've got such a number. When you think of 0.1, it will give you a hint. The half of 0.1 is 0.05. Just add a 0 where there's a 1, and the next add 5. 5 plus 5 will give us a 1 there. So equally, here the half of 0.01 is going to be 0.0005. That's the half of it. Okay, so that would be plus 0.0. We'll introduce an extra 0 and then add a 5. Plus half minus 1 gives us negative half. Okay, so we have half multiplied by negative half. Now dividing by 2 is the same as multiplying by 1 over 2. And then that squared, just count the number of zeros and double them. So we have 3 of them. So they now become 6 of them. So that would be 1, 2, 3, 4, 5, 6. Since it's a 1 at the end. If you want, you can go on and multiply, of course. 0.001 multiplied by 0.001 and do all, and then count the number of decimal places, which should be 1, 2, 3, 1, 2, 3, 6. Okay. Okay, so how do you proceed from this point? Is there anything that needs simplification? Of course, this part. So that's going to be a negative 2 times 2 times 2, that's 8, 1 over 8, and then we have 0 0.0000001. Okay, and then we have 1 plus 0.005. Okay, so now at this point the basics of binomial are already used up, and all we just need to now is apply our basic mathematics to simplify the questions at hand. Now 1 over 8, this can be easier if you take it in terms of multiplications, right? Take this into a decimal, 1 over 8 into a decimal. It will be easy to deal with decimals than you deal with a fraction and decimal. Remember, I'm assuming calculators are not allowed. So 1 divided by 8, 8 into 1, we can't divide that, so we introduce a 0. Okay, and then into 10, that's 1, and then remain with a remainder of 2. Into 2 we can't, so we add a 0. That gives us 2 times. That's of course a 16, so a difference of a 4 again. Into a 4 we can't, so add a 0. 40, that's a 5. So 0.125 is the value that can represent 1 over 8. 0.125. Now 0.125 can easily be multiplied with 0.001. I can show you how. So we have 0.00, how many zeros have we? 5, multiplied by, what do we have? That's a 0.0125, right? 0. So we'll just take it at the end. So we have 5, we have 2, we have 1, and then 0.0. So basically when you're multiplying, you ignore the decimal places and then you come and count them at the end of it all. 5 times 1 is a 5. 5 times the 6 zeros, that would just be 6 zeros. How many of these? 5, 6. The next number is 2, and then 6 zeros. The next number is a 1, and then 6 zeros. Next number is a 0, which of course will just introduce all unnecessary zeros, eh? So we don't need them. So we have 5, 2, 1. Now decimal places, this is now where we've wasted a lot of time. We could have just looked at 0.125 and would have moved just the number of decimal places. So that's all we needed. So how many are there? So 1, 2, 3, and then here we have 1, 2, 3, 4, 5, 6. 6 plus 3, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. How many zeros have we put? 1, 2, 3, 4, 5, 6. So 6 zeros. 1, 2, 3, 4, 5, 6. So 0 point, and then 125 at the end. If you want, you can use a calculator to prove that. Okay? 0 point over zeros, 1 multiplied by 0.125. So you find that it's going to be that with all these zeros. Okay? How many zeros are there? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Remember, it's 9 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need one more 0. Okay, so 7 zeros there. So you've now learned a shortcut. So every time you're trying to perform all that multiplication, you don't need to go that far. Just as long as there's a 1 at the end, you just count the number of decimal places and then add the numbers that are there at the end. So that's what we have. Now this is only for this part. Okay, so we now have 1 plus 0.005, which of course we can add, can give us something we can easily deal with. So we have 1.005, because 0 plus the 1 gives us the 1, and then we're subtracting the 0 point. Remember these zeros were 7. Okay, so we just subtract these two numbers and then you'll be able to, so you're able to subtract, I believe. In case you've forgotten and you've got all the time in your assessment to subtract, so here now you write according to the decimal places, just like we did in the previous one, but here the difference is the way you find the answer, that's the way the answer will remain. Okay, to just zeros, unlike the previous one where we were counting the decimal places at the end. So you can now subtract. Okay, so I'll leave that to you. But when you subtract, you should get something like 1.000499875. How do you start? You can't subtract a 5 from a 0, so obviously that will remain a 4. 9, 9, 9, 9, 10. That's a 5. That's a 7. That's an 8, 9, 9, 4, 0, 0, 0, 1. That's where that value is coming from. So I had to take all these minutes just to show you how you can handle this. Now that I've shown you a practical example, now we can go about all these complexities. The next ones I'll just try to rush into them and just use the calculator to manipulate them for faster simplifications. Okay, so here we have 1 divided by that. How does that look? What does that mean? So you can actually present that as to be 1.02. Now that we've made this a numerator, it implies 2 will be raised to the power negative 2. And of course what it implies is the one that is on top is still there, but there's no need of us to show it, unless if we had a number like a 2, it would have remained. Okay, so that's what you do when you've got a fraction. Now we can take it again in the form of 1 plus a value that is less than 1, which in this case will be 0.02. Now don't forget our formula that we're dealing with, that is was 1 plus nx plus n minus 1 over 2 factorial x squared, and so on and so forth. So we'll plug in our values. I just want to make sure we did 6 decimal places for this question. Are they 6? So let's just try to count. So 1, 2, 3, 4, 5, 6. You can cut from this point. 1.000499. Now if you add a 1, it brings some issues, huh? So it becomes a 0, then it becomes a 0, then it becomes a 5, 0, 0, 0.1, something like that. Yeah, so how do we proceed from here? We have 1 plus our value of n in this case is a negative 2, so we have negative 2. Our x is this part, that's 0.02, negative 2 minus 1 over 2 factorial. X squared is 0 0.02 squared. You can proceed if you want. If you're using a calculator, especially, you would want to proceed to the next term. That would obviously be n minus 1, n minus 2. Now here to be 3 factorial, and then x to the power 3. So practically what happens is, if you've noticed a trend, these first two are already part of the previous term. So that would be negative 2 multiplied by negative 3, which would be negative positive 6, multiplied by n minus 2, which is negative 2 minus 2, and then x to the power 3, our x is 0 0.02. The power 3, over 3 factorial. So we have 1 minus 0 0.04. Negative 2 times negative 3 is the negative 6, divided by 2. This is actually positive 6, divided by 2 on the bottom. 2 factorial is 2 times 1 is just 2. So that gives us just a positive 3. Now 0 0.02 squared. 0 0.02 squared gives us 0 0.0004. Okay, plus, now negative 2 minus 2 is a minus 4 times the 6, gives us a negative 4 times 6 is what? 24. So negative 24. 3 factorial is 3 times 2 times 1, which is like a 6. And then don't forget we have 0 0.02 raised to the power 3, which is 0 0.0000. How many zeros are there? That should be 5 of them. Okay. Now at that point, that value is supposed to be divided by 6, multiplied by negative 24, added to 3 times 0 0.004, and then minus 0 0.04 plus a 1. So the value I'm getting is 0.961168. How many decimal places are these? 1, 2, 3, 4, 5, 6. So that becomes our answer in such a case. Now, is that true? What if we got our calculator and tried it out on a calculator directory? So 1.02 squared is something like 1.0404. Now 1 divided by that. So the value I'm getting is 0.96116878. So you can see that it's actually close to the accurate value by using binomial expansions. So that's what binomial expansions can do. It can simplify these expressions. Okay. So in a case where you don't have a calculator, you can still use binomial to manipulate all that, and that proves that binomial is actually accurate. Now when you look at this one, the third one, feel free to pause the video. Whenever you look at the square root, we say this converts to half as a power. Now in dealing with a third root, what that implies is it's the third root 1 over 3, which we can express as 1 plus 0.03, and you can easily manipulate it from this point. How? Don't forget our formula, 1 plus nx plus nn minus 1 2 factorial x squared plus same trend. Now introduce an extra term, it becomes 3 factorial plus. If you're having issues remembering this formula, watch our introduction video. I explained on how you can easily remember this formula. Okay, let's proceed now. our n in this case is 1 over 3, our x is 0.03 plus 1 over 3, 1 over 3 minus 1 over 2, 0.03 squared. So to ensure that the next part is easier, we can simplify this, which is already existing there. So 1 over 3 subtract a 1 is negative 2 over 3, right? Negative 2 over 3. So we have negative 2 over 3 for the first part, and then we have a 1 over 3 minus 2 divided by 3 factorial, which is just 3 times 2, which gives us a 6, and then x to the power 3, of course that's 0.03 raised to the power 3. Now at this point all you just need is just to grab your calculator and perform the required calculations. So I'll start 1 over 3 multiplied by 0.03. So we have 1 plus 0.01. The next part, 1 over 3 minus 1 is negative 2 over 3 times 1 over 3 divided by 2 multiplied by 0.03 squared. So that gives us negative 0.001. Then the last part, negative 2 over 3 multiplied by 1 over 3 minus 2. So I'll do this again. 1 over 3 minus 2 multiplied by negative 2 over 3 multiplied by 0.03 to the power 3 divided by 6 gives us 0.000005, and then we can add these parts as well. So we have a plus 1 plus 0.01 minus 0.001. So the value I'm getting is 1.009905. 6 decimal places should be. Okay, so for the sake of cases where calculator is not allowed, it's okay to end up to this point, and I believe you're able to manipulate all that to avoid complications of numbers such as that. Okay.